Hello friends, today we are going to discuss about the important points of atomic structure. As already I have made one video for the atomic structures. In this video I specially describe what the important terms of this chapter, whatever the terms you should remember before giving the examination. If I talk about the atomic structure chapters, important terms, it comes about the electron discovery. Who had discovered the electron? Electron, it was discovered by J.J. Thomson, and it is a negatively charged particle. Electron is composed particle of the cathode rays. Cathode rays which were discovered by the William Crookes and J.J. Thomson. Cathode rays travel in a straight line. Cathode rays consist of negatively charged particle which is known as electrons. Proton was discovered by E. Goldstein, and it is a positively charged particle, and it is a component particle of anode rays. Anode rays travel in a straight line. These are the positively charged. The E by M ratio of these rays is smaller than that of electrons. And neutron was discovered by James Chadwick in 1931 by the following reaction. You can see here the beryllium, when the helium rays were, alpha charged particle rays were bombarded on the beryllium, then the carbon, and one neutron was formed. A neutron does not carry any charge. There is no positive, no negative charge. So first of all, you should remember before starting the chapter that who had discovered the electron, proton, neutron, what are the cathode rays, what are the anode rays, and who had discovered them, and in which year they have discovered. Now if I talk about the atomic number, the number of protons present in the nucleus of the atom is called atomic number. Means how many protons are present in the atom, that is called their atomic number. It is specially denoted by capital Z. Atomic number is equal to number of positive charge on the nucleus, that is equal to the number of protons in nucleus, that is equal to number of electrons in the neutral atom. If I talk about the mass number, it is the number of molecules or nucleus of the number of protons and neutrons. If I talk about the number of nucleons, means what is the number of nucleons? It is the sum of protons and neutrons. That is called atomic mass number. It is denoted by capital A. So mass number A is equal to number of protons or atomic number plus number of neutrons. Means A is equal to Z plus N. So that's why N is equal to A minus Z. So remember, dear students, about the neutrons. Neutrons, if you want to calculate from any atoms, then you have to just do atomic mass minus atomic number. By that calculation you'll get the number of neutrons. If I talk about the electromagnetic radiation, these consist of the electric and magnetic fields that oscillate in the direction perpendicular to each other, and the perpendicular to the direction in which the wave is traveling. They do not need any medium or for propagation. For example, X-ray, gamma ray, all these electromagnetic radiation travel with the velocity of light, that you know very well. What is the velocity of light? That is 3 lakh kilometer per second, means 3 into 10 to the power 8 meter per second. What is wavelength? Can you tell me? It is the distance between the two nearest crest or trough, right? So the unit of wavelength can be meter, centimeter, nanometer, angstrom. 1 angstrom is equal to 10 to the power minus 10 meter or minus 8 centimeter. If you talk about any other measuring, then generally you should remember about that wavelength is lambda. Lambda, generally it is measured in the nanometer and angstrom. Now if I talk about the frequency, it is the number of waves which pass through a point in 1 second. It is the number of waves which pass through a point in 1 second, that is called frequency, and its SI unit is hertz. Hertz or cycle per second, means C is equal to lambda into nu. The velocity is the product of frequency and wavelength. Velocity is the distance covered in 1 second by the wave. Velocity is the distance covered by 1 second. Once covered by 1 second is frequency and wave. So the product of wave and frequency is called velocity. So C is equal to nu into lambda. Wave number, if I talk about, it is the reciprocal of wavelength or the number of wavelengths per centimeter. That is called wave number. Okay, so these were the wave theories ingredients. Now let's talk about the Planck's quantum theory. Radiant energy is not emitted continuously but discontinuously. It is the form of packets of quanta. Energy associated with each quantum is directly proportional to the frequency of the radiation. E is directly proportional to nu. E is equal to h nu, where h is called the Planck constant, and the value of Planck constant is 6.626 into 10 to the power minus 34 joules second. Energy associated with all the quanta, which is given by E is equal to nh nu, where n is the number of quanta. A number in the case of light is called a photon. Thomson model of atom, if I talk about the positively charged of the atom is like a sphere in which the negatively charged electrons are embedded. It is also known as plum pudding model. Now if I talk about the Rutherford alpha scattering experiment, a beam of alpha particles was made incident on this thin gold foil that was 0.0004 centimeter thick, and across the foil a screen of zinc sulfide was kept. So Rutherford model of an atom consists of positively charged heavy part called nucleus, where most of the mass of the atom is concentrated. Protons and neutrons are present in the nucleus. Size of the nucleus is very small compared to the size of the atom. Around the nucleus there is extranuclear part in which there are around the electrons are there. Electrons revolve around the nucleus in a circular orbits like planets around the sun, and they are called planetary electrons. What are the theory by which the Rutherford model was failed? Rutherford model: an electron belonging to a charged particle under acceleration around the nucleus should lose energy continuously, and it should move closer and closer to the nucleus due to the loss of energy, and ultimately should spiral down into the nucleus. So the atom should collapse, but the atom by itself, it is stable. This thing, it doesn't happen actually. That was the failure of the Rutherford atomic model. Now let's discuss about the Bohr's model of atom. And it will ask you, what is the Bohr's model of atom? So an atom has a nucleus which is a positively charged, and it is very small. It is a continuous protons and neutrons. Negatively charged electrons are moving around the nucleus. Around the nucleus, you know very well what happens. The electrons moves in a circular orbit, and the electrons cannot just revolve anywhere, but it can only revolve around the nucleus in a certain permitted orbitals, where the angular momentum of the electron is equal to nh by 2 pi, or mvr is equal to nh by 2 pi, where n is equal to 1, 2, 3, and r is equal to the radius of the orbital, and h is equal to Planck constant, that is the 6.626 into 10 to the power minus 34 joules second. In each stationary orbit, the electron has a definite quantity of energy. In its own stationary orbit, the electron is said to be ground state. An electron in the ground state can absorb a certain amount of energy and can get shifted to the higher energy state called excited state. In the excited state, the electron is unstable and jumps back to the ground state within the emission of energy. The energy is absorbed or emitted during a transition, which is equal to the difference in energy of the two orbits. The important formula which you should remember to solve the numericals: you can see the radius of the orbit and the velocity of the electron. Radius is directly proportional, or you can just remember the formula: r is equal to n square by z. r1 by r2 is equal to n1 square by n2 square into z2 by z1. R is equal to 0.529 into n square by z angstrom. This is the most important formula, especially for the Bohr radius atom. You should remember this formula. If I talk about the velocity is also directly proportional to z by n. So v1 by v2 is equal to z1 by z2 into n2 by n1. So v is equal to 2.188 into 10 to the power 8 into z by n centimeter per second. Remember these two formula: velocity of the electron and the radius of the orbit. Now if I talk about the energy of the electron, En is equal to minus 2 pi m e to the power 4 z square by n square h square. But En is equal to minus z square by n square. E1 by E2 is equal to z1 square by z2 square into n2 square by n1 square. So these are the energies of the electron. Now energy of the electron in the different units, if you want to convert in the different units, electron volt per atom, then it is minus 13.6 z square by n square. If you want to convert into kilojoule per mole, that is minus 1312 z square by n square. If you want to convert into the joule per atom, that is minus 21.79 into 10 to the power minus 19 z square by n square. If you want to convert into the kilocalorie per mole, then it is minus 313.6 z square by n square. Very, very important formulas for the exam. Remember this formula for solving the numerical problems. Now let's discuss about the different modes of transition between the two orbits. Here you can see the difference of energy. If electron wants to jump from n1 to n2 or n2 to n3, then if I talk about the delta E, so here you can see the difference between the energies and what will be the sum of energy. If from n1 to n3, if they want to go, then the difference between the energies, you can see delta 1, delta E1, delta E2, delta E3, right? Velocity V1, is equal to V2 plus V3, or that's the frequency. If I talk about the lambda, 1 by lambda is equal to 1 by lambda 2 plus lambda 3, right? So here what I mean to say is just how to calculate the energy difference. E is equal to h nu and delta E is equal to h2, or you can say that E2 minus E1, the total number of spectral lines for a transition number of lines, that is the sigma n2 minus n1. For example, if the transition from 6th orbit to the 2nd orbit, so the number of lines will be sigma 6 minus 2, means sigma 4. Sigma 4 means 4 plus 3 plus 2 plus 1 plus 0, that is equal to 10. So from 6th orbit to 2nd orbit, how many number of lines are there? So there are total 10 lines. Now let's discuss about the Rydberg equation. Wave number is equal to 1 upon lambda is equal to r into 1 by n1 square minus 1 by n2 square into z square, where n2 is always greater than n1. Are the number of orbits, z is equal to atomic number, and r is equal to Rydberg constant. The value of Rydberg constant is 109677 centimeter inverse, or you can say 109678 centimeter inverse. Here you can see the hydrogen spectrum, name of the series, spectral lines, N1 and N2 values. If I talk about the Lyman series, in the Lyman series is especially observed in the ultraviolet rays, where N1 value is 1 and N2 value is 2, 3, 4, 5, 6, so on. Similarly, if I talk about the Balmer series, it is specially observed in the visible region. N1 value is 2 and N2 value is 3, 4, 5, 6, 7. If I talk about the Balmer series, it is visible region, and especially N1 value is 3 and N2 value is 4, 5, 6, 7. In the Paston series, infrared rays, N1 value 3, N2 value 4, 5, 6, 7. In bracket series, infrared rays, N1 value 4, N2 value 5, 6, 7, 8. If I talk about the P1 series, infrared rays, N1 value 5, N2 value 6, 7, 8, 9. If I talk about the Humphrey series, infrared rays, N1 value 6, N2 value 7, 8, 9, 10. Now let's talk about the spectral lines. How many spectral lines are there, or line of the maximum wavelength or minimum frequency, right? So here you can see in the Lyman series, N1 is equal to 1, N2 is equal to 2. Line of minimum wavelength or line of maximum frequency, N1 is equal to 1, N2 is equal to infinity. Remember, the difference is N2 is equal to N1 plus 1. That is the line of minimum wavelength and minimum frequency, and line of minimum wavelength and maximum frequency. Maximum means what? Infinity. So here the minimum means Lyman series N1, Balmer series N1 is equal to 2, Paston series N1 is equal to 3, bracket series N1 is equal to 4, P1 series N1 is equal to 5, and Humphrey series N1 is equal to 6. If I talk about the minimum frequency, then also N2, especially for the Lyman series, N2 is equal to 2, Balmer series N2 is equal to 3, Paston series N2 is equal to 4, bracket series N2 is equal to 5, P1 series N2 is equal to 6, and Humphrey series N2 is equal to 7. Now if I talk about the line of minimum frequency, that all the N2 values as I have said, but if I talk about the maximum frequency, then N2 or N3 or N4 or N5 whatsoever, N2 values in all the series will be infinity. Now let's talk about the drawbacks of Bohr's model. What are the drawbacks of Bohr's model? It is only applicable for the one electron species like hydrogen, helium plus, lithium 2 plus, beryllium 3 plus. It does not explain the Stark effect or Zeeman effect. It has no explanation for the line spectrum or fine spectrum. It is not in according to the de Broglie dual nature of the matter and Heisenberg uncertainty principle. What was the dual Broglie nature of matter? All moving objects have a particle as well as a wave nature or wave character. The wavelength associated with the moving particle is called de Broglie wavelength. This principle is significant for the microscopic particle like subatomic particles, electron, proton and neutron, and does not have any significance in the daily life. Lambda is equal to h by p or lambda is equal to h by mv. If I talk about the Heisenberg uncertainty principle, it is impossible to measure the simultaneously both the position and the momentum of a particle together with the absolutely accuracy. That's why delta p into delta x is greater than and equal to h by 4 pi, where delta p is the uncertainty momentum and delta x is the uncertainty in position, and h is the Planck's constant. What is wave mechanical model of the atom? The classical mechanics could not describe the behavior of the electrons correctly. Therefore, a model was proposed which could incorporate uncertainty principle and dual nature of matter. This approach was called quantum mechanics or wave mechanics. It was developed independently by the Heisenberg and Schrödinger. Let me talk about the Schrödinger wave equation. Schrödinger described the behavior of the electrons in the form of mathematical equation called Schrödinger wave equation. d square psi by dx square plus d square psi by dy square plus d square psi by dz square plus 8 pi square m by h into E minus V psi is equal to 0. E is the total energy of the electron, V is the potential energy of the electron. The only dependent variable in Schrödinger wave equation is the wave amplitude or wave function, that is psi. Psi depends on the coordinates of the particle. So in the case of electron, psi square is taken to be probability of finding the electron at a given point at a given instant of time. So that was Schrödinger wave equation. Now let me discuss about the quantum numbers. There are a set of 4 quantum numbers assigned to describe the electron positions in an atom. Principal quantum number, it gives the number of shell to which the electron belongs. Its value can be 1, 2, 3, 4, 5, 6, 7. Larger the value of n, greater is the distance from the nucleus and the energy of the electron. Maximum number of electrons in a cell can be 2n square. Azimuthal quantum number, L, also called angular quantum number or subsidiary quantum number. For every value of n, L can be 0 to n minus 1. Value of L corresponds to the subcell or sub-level of energy within a cell. So order of energy and distance from the nucleus. F is greater than D is greater than P is greater than S. Means F has the maximum distance from the nucleus, less is D, less is P, and the nearest is S. So orbital angular momentum of the electron, very important formula. If you want to calculate the orbital angular momentum of an electron, is equal to h into under root L into L plus 1, that is equal to h by 2 pi into under root L into L plus 1. Angular momentum of an electron, h by 2 pi under root L into L plus 1. Now let's discuss about the magnetic quantum number. It gives the number of preferred orientations of the electron in the presence or pressure of the magnetic field, which are called orbitals. For every value of L, m can be minus L2 plus L through 0. Total value of m for every value of L is 2L plus 1. If I talk about the s orbital, 0, so magnetic quantum number 0 but 1 orientation. P, azimuthal quantum number 1, minus 1, 0 plus 1, 3 orientation. D, 2, minus 2, minus 1, 0 plus 1 plus 2, 5 orientation. F, 3, minus 2, minus 1, 0 plus 1 plus 2, 7 orientations. Orbitals of the same subcell have same energy and are known as degenerate orbitals. Spin quantum number. An electron revolves around the nucleus and also spins about on its own axis. Spin produces angular momentum in a particular direction. S is equal to plus half for the clockwise spin and minus half for the anti-clockwise spin. Rules for the filling of electrons in the orbitals of an atom. Pauli exclusion principle. No two electrons in an atom can have the same set of 4 quantum numbers, as an orbital can have a maximum of electrons with the opposite spin. Aufbau principle. Aufbau was a German. Aufbau is a German word that means building up. Filling of electrons in a various subcell of an atom take place in the increasing order of energy, starting with the lower most, that is 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, so on. Bohr-Bury rule, n plus L rule. The subcell will lower value of n plus L is filled first. For example, 4s is filled before the 3d because of the following rules. You can see here 4s and 3d. N value of 4 is 4 and 3 is 3. L value of s is 0 and d is 2. So n plus L value for 4s it's 4 and 3d it's 5. So first 4s electron will be filled and then 3d electron will be filled. Hund's rule of maximum multiplicity. This rule is used for the filling of electron in degenerate orbitals. During filling of electrons in degenerate orbitals of a subcell, pairing does not take place till each orbital gets 1 electron with the parallel spin. Atomic number 21 to 29, you can see scandium, 24 chromium, 25 magnesium, 26 iron, 28 nickel and 29 copper. Electronic configuration: argon 4s2 3d1 for scandium, argon 4s135 for chromium, argon 4s235 for manganese, argon 4s236 for iron, argon 4s238 for nickel, and argon 4s13010 for copper. In copper, Z is equal to 29. 4s13010 is there because D10 is more stable, fulfill the configuration. In chromium also 4s135 is therefore because D1 is more stable, half filled configuration. That's why chromium and copper both are stable configuration. Similarly, if you want to calculate the electronic configurations of iron, if I talk about the Ni2 plus, the electrons are first lost from the 4s and then from 3d. So Ni atomic number is 28. The general electronic configuration argon 4s238, Ni2 plus, 4s0 and 3d8 will be the remaining. 3d8 means it is having 2 unpaired electrons, so it is paramagnetic in nature. Spin magnetic moment, that is under root n into n plus 2 bm, Bohr magneton, where n is equal to number of unpaired electrons. So if I talk about the Ni2 plus, it has 2 unpaired electrons, 2 into 2 plus 2, 2 into 4, that is 8, under root 8, it is 2.9 something, that is the value of spin magnetic moment. Now shape of the orbitals, as orbital shape will be spherical, symmetrical. P orbital shape will have 3 orientation, dumbbell shape. D orbital have 5 orientation and double shape. And if I talk about the d orbital shapes, you can see here the dz square, dx square, y square, dxy, dy square, or dyz and dxy. So you can see here the magnetic quantum number 0, +1, -1, +2, -2. So dxy, dyz, dx square, y square, dz square. Along the axis, between the axis, xy, yz and xz, they are the between the axis, and x square, y square and z square is along the axis. You can see they have been distributed into the 2 parts, Eg and 2Tg. So these were the important points of chapter 2. Hope all of you have enjoyed this video. Thanks for watching. Don't forget to like and subscribe the channel. Thank you very much. Thank you very much, guys. Don't forget to like and subscribe.